So we've got this example with brushing. But the problem here is it's super duper slow. There's a lag here. It's not really snappy, you know? I'm going to talk about ways that you can address performance problems like this with React. Make it work, make it right, make it fast. This is one of my all-time favorite philosophies or approaches for developing software from Kent Beck. This is the approach that I use in my work, and I encourage you to do the same because otherwise you're at the risk of premature optimization, optimizing things that don't even need to be there. The idea here is do the first pass of something, just make it work. You know, do whatever ugly hacks you need to, and then refactor it to make it right. You know, make it good quality. And then only after making it right, making it look good, refactoring the code to be manageable, only then do you do the third step of making it fast or doing performance optimizations. That's the gist of make it work, make it right, make it fast, and right now we're on the last step, making it fast. So, how do you make things fast with React? The first step of making something fast is identifying why it is slow. What parts of the code are making this go slow? There's something that takes a long time every time I brush here. One thing to keep in mind is that our brush extent state, which changes every time we move the brush, is kept at the top level app component. What this means is that this app component function gets executed over and over and over again every time the brush changes. So everything inside of the app, all the other functions that get called by this top-level app function, they get called every single time the brush moves. As one example of some code that executes every time the brush changes, this data.filter call needs to iterate over all rows of the dataset to compute the filtered data. This one strikes me as just fine because that's actually necessary to do every time the brush changes. But my main question is, are there any other parts of the code that loop over the entire dataset every time that don't need to? Like maybe we could just loop over the entire dataset once and then use that result for the future renderings. Let's see if we can find something like that. Our app component renders the bubble map and the date histogram. The date histogram, let's see, is the date histogram looping over all the data? All these computations are pretty much fine to do each render because they're relatively inexpensive. Although this one, generating the number formatter, that could definitely be moved outside of this function. So that's one little optimization that I'm going to do right now, although I don't think it'll give us that much performance. Are there any places where it loops over the entire data set? Well, look at this right here. It's computing the domain extent from data and xValue. It's also computing the binned data over and over again from the original data. I would guess that computing the binned data is the most expensive operation that's being done each time the brush changes. And think about it, it really is not going to change at all when the brush moves. I mean, this is the histogram. The histogram's not changing. So why recompute the values again and again and again every time the brush changes? If only there were some way to compute the binned data just the first time that this is rendered, and on subsequent renderings just use that data that was computed the first time around. That way the code would not need to look at all the data over and over again on each render, and then hopefully our brushing would become snappy. But how would we even do that? How would you know when to compute binned data and when you can use the old previously computed version of binned data? Well, there's actually a term for this. It's called Memoization. Memoization is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls and returning the cached result when the same inputs occur again. React itself provides a utility for memoizing values. It's called useMemo. The way you can use it to compute a memoized value is to call useMemo and pass as the first argument a function that doesn't take any inputs, and that function computes some expensive value with some inputs. In order for useMemo to know when that value needs to be recomputed, you need to pass as the second argument to useMemo an array of those values called dependencies. In our case of the binned data, the dependencies include things like the data itself and maybe some other stuff like scales, which ultimately depend on just the data itself and maybe the height of the screen or whatever. But the point is, these things are not going to change between renders when you move the brush. So we can use this React hook, useMemo, to memoize our expensive computations and speed up our code. So let's give it a try. I'm going to start by memoizing the computation of our entire x scale. The construction of our x scale depends on data, x value, and inner width. We can invoke useMemo like this, where the first argument is a function that returns the timescale, and the second argument is an array. That array needs to contain the dependencies, namely data, x value, and inner width. And then I'll just auto-format that with prettier using Alt-P. And this is not working because we have not imported useMemo from React, so I'll do that. Now our brushing is working again, but it's only computing the x scale once on the first render. But how do you know this is working? How do you know that this value is really being memoized? Well, let's do a little experiment to just confirm this. In our call to useMemo, the first argument is this function, which is implicitly returning our x scale, this instance of scale time. I'm going to add a console.log. We'll say console.log computing x scale, and then we need to explicitly return the scale and close out the function body. Now, if we look in the console, we see that it printed out computing x scale, and here's the moment of truth. As I brush, it does not print out computing x scale ever again. That means that our memoization optimization worked. It's only computing the x scale once. But the brushing still doesn't feel snappy. We need to do this optimization everywhere where the code is looping over the entire data set unnecessarily. So let's just look for all the other occurrences where we can use this optimization. I'm going to change this back to the cleaner version that doesn't have the console.log. The next place where we can apply a similar optimization is in computing our binned data. We can say useMemo, pass a function that returns the binned data, and as the second argument here, we need to pass in the dependencies, which are x value, x scale, start, stop, which are computed right here. And I'm pretty sure they're only used inside of here. So you know what? I think I'll just convert this to a function with a body and return that statement there. And then move the computation of start and stop to be inside of that function body. That way our dependencies are simpler. All we need is x scale because start and stop are computed, derived from x scale. The data is also a dependency, and y value is another dependency. Now this should still be working. All right, sweet. And because there are so many dependencies, I do just want to double check that this is working. Console.log computing binned data. And we've got it once, and when we brush, oh no, we have it many times. That means that one of our dependencies might be changing on each render. It's not x scale because we're using the memoized value. It's not data because that's stored in a piece of state. That's not going to change. It could be that x value and y value are being redefined on each render. And I just moved that just because I like to see things like this next to each other. The ordering of the things in this dependencies array doesn't matter. So, are these being redefined on each render? Let's check where are x value and y value defined. Well, here's the definition of y value, and it is in fact being redefined every single time as a newly minted function. One way that we could solve this is just by moving these things that don't depend on anything else out of that function with these other things over here. Now, y value is just being defined once when the module is loaded, but it's not being defined again and again every time this component is executed. Now, when we brush, it's not computing the binned data over and over again. All right, that's good. This is progress. So I'll get rid of that console.log and move on to other places that we could possibly optimize. In computing the y scale, the code iterates over all of the binned data. We could memoize this entire scale as well. So let's say useMemo, pass a function that returns that scale, and as the second argument, pass an array of dependencies which includes binned data and inner height. All right, now the brushing, I don't know, it still feels a little laggy. It feels a little faster than it did, but I think there's still more that we could do. Even after those optimizations, our brushing still feels a bit sluggish. We've optimized our date histogram. Now let's take a look at the bubble map. Is this bubble map component doing anything that loops over the entire data set or loops over all the shapes of the countries? That's another data set that could be looped over and provide some expensive computations. Size scale depends on looping over the data to compute the maximum over the data of our size value accessor. Now that I think of it, there's actually a sort of a bug here. That is that the size scale is based on data in this context, which is actually the filtered data in the index.js context. Actually, that shouldn't change. The size scale should just be dependent on the original full data set, and it shouldn't change as the brush changes. So let me fix that. I think the easiest way to approach this is to take as another prop the filtered data, where the understanding is the data prop is the original full data set and the filtered data is the subset resulting from the brush filtering. And that is what we pass in to the marks, but when we compute the size scale, that should just use the original data. Now we need to update index.js to pass these new props. Instead of passing data as filtered data, we can pass data as just data and filtered data as filtered data. And these are both in scope here. Here, filtered data is computed, and here's data. And it's still working, which is good. Now we're in a position to memoize the size scale. First, we need to import useMemo from React. And then we can use it here useMemo passing a function that returns our size scale, and the second argument will be the array of dependencies, namely data, size value, and max radius. At this point, I know that this function will be invoked every time because one of its dependencies, max radius, is redefined as a newly minted function on each invocation of this component. To solve that, I can move the definition of that value outside the component itself. Now we have memoized the size scale. But there's still some lag. Where else could we optimize? Let's take a look at the marks component. In the marks component, we're rendering a bunch of stuff that does not change as the brush changes, like the sphere, the graticules, the land, and the interiors. The only thing that really changes when the brush changes is this segment here. Generation of these path strings for all countries is pretty expensive. What this code here is really doing is building up this JSX, creating a bunch of objects and a bunch of new strings for each of these features every single time that this is rendered. One thing that kind of blew my mind is that useMemo is not limited to just things outside of JSX. You can actually memoize the JSX itself. Because ultimately, it compiles down to JavaScript. This JSX here ends up getting transformed to the content of bundle.js. And here's the transpiled version of that JSX. It's just invocations of react.createElement, which returns an object. So in this code here, for each and every land feature, it's creating a new object that's a path, and it's also generating that big SVG path string for that feature. What if we memoized all of this? That might be a big help. I'm pretty sure with the React virtual DOM diffing, if you return the same exact React element, then it won't even do any deeper diffing than that. So the upshot of this is that the React rendering engine, if we memoize all of this, it should just not have to do any work at all regarding all those background shapes on the map every time the app re-renders due to the changing of the brush. So let's try that. Let's try memoizing this JSX. I know for a fact that all of this stuff does not change as we change the brush because it doesn't use the data at all. So I can wrap that in one of these blocks. The curly braces let you escape into JavaScript, and then invoke useMemo. The first argument will be a function that returns all of this JSX here. But since you can't return multiple top-level JSX elements, I'm going to use a fragment to contain all of this stuff. And the second argument to useMemo will be an array of dependencies. And let me just reformat that there. The dependencies include path, graticule, land, and interiors. This should work. useMemo is not defined. Looks like I forgot to import it in this file. Import useMemo from React. Alright, it's running again. And it's snappy! Oh my god, this is such a relief. This feels so much better and so much faster. It's just incredible. Alright, well, I'm satisfied with this. It's now silky smooth like butter. And even though there may be more things we could memoize and optimize, it's not worth it. Because you just need to optimize the things that are really causing problems. And who knows? Maybe if I had only memoized this JSX generation with the background paths, that would have maybe been all that I needed to do. But since there are a lot of elements in the data array, I went for that first because I thought that probably would be the main cause. And who knows? You could use profiling techniques like setting timers before and after the code to actually measure how long each part of it takes. Another amazing tool in your toolbox is the Performance tab of the Chrome DevTools. With this, you can hit record, do some stuff like brushing, and then say stop, and then you can see which function calls take up the most time. Here you can see that these top-level things are mouse move events, and handling each one, including the re-rendering from the brushing, takes 17 milliseconds. That's pretty good because the fastest your monitor can display things is 60 frames a second. If you take 1 second, or 1,000 milliseconds, and divide that by 60 frames, that's about 16 milliseconds between frames. So if your computation takes 16 milliseconds or less, then you pretty much get the fastest updating display that you possibly can. At this point, though, you could dig deeper and see which functions are taking up the most time here. But it gets a little tricky with React because you're looking at minified React functions that are doing who knows what. But anyway, that's the overall approach that you can take for performance optimization with React.